Good afternoon, class, and welcome back to Chapter 7.2, Solving Linear Systems by Substitution. So as you saw in Chapter 7.1, we were graphing the linear systems to find that point of intersection. So now we won't be graphing, we'll be looking at two linear equations and using substitution to find out that intersection point. So we're still going to get this intersection point. We still will get an ordered pair as our solution. But it will not be by graphing anymore. It's going to be by substitution. So let's talk about that. So here are the steps. And again, I'm going to read these, but then we'll go over these in the problems, in the examples. And if you have any questions, make sure you email me. But replay the video a couple times so you can see. The thing that I like about substitution is, obviously, number one, we don't use a coordinate plane, and obviously you saw how I drive or how I draw a coordinate plane in class. It's not very accurate. So I do like this. It's a little bit more algebra-esque, you could say. So here are the steps. Solve one of the equations for its variable. So we have two linear systems. We're going to solve one of the equations for one of its variables. So this keyword one pops up twice in this sentence. So we're going to look at both of them and solve for x or y, and we'll talk about how you're going to figure that out. Substitute the equation or the expression from step one. So after you solve for x and y, you're going to substitute that expression from that step into the other equation and solve for that other variable. Then after that, you're going to substitute the value from step 2 into the revised equation from step 1 and solve. Check the solution in each of the original equations. Very similar to how we checked it with graphing. We're going to check it the same way for substitution. And of course, as many of you guys may have noticed, there should be a U, not a V right there. So let's try this out here. Example 1. Negative x plus y equals 1 and 2x plus y equals negative 2. So we're going to solve one of the equations. So we're either going to pick equation 1 or equation 2. And we're going to solve for one of the variables. So we're either going to solve for x or y. Okay? X or y. Now, in my opinion, in the problems that you'll be focusing on, I would select one that has a coefficient of a positive 1. You want to get that alone. Okay, so both of these y's have a coefficient of 1. So I would leave y here and I'd solve for y. So I'd add the x over here. So in this equation I have y equals x plus 1. Okay. So now what rule 2 says is you found this, and now you're going to plug in what you found. So we found that y equals. So we're going to plug what y equals in for y. So now we have 2x plus the x plus 1, which is y, equals negative 2. Okay, and we do that so that we only have one variable now, and we can solve and find out what that equals. Okay, so now combine like terms. We have 3x plus 1 equals negative 2. Subtract 1, 3x equals negative 3. And divide by 3 and you get x equals negative 1. So, sorry about that. So now we take this value, negative 1, and we're going to plug it back into the equation that I created from step 1. So negative 1, plug it in for x, plus 1 equals 0. So y equals 0. Now what it says on step 4 is to plug it Come on. Work with me. Sorry, my pen's not working right now. There we go. 2x plus 1y equals negative 2. So what it says in step 4 is take your ordered pair then and plug it into both equations to make sure it works. So we have negative of a negative 1 plus 0 equals 1. Well, we know negative of a negative 1 is 1. 1 plus 0 is 1. So that checks out in the first equation. So the second equation, we know 2 times negative 1 plus 0 equals negative 2. Well, 2 times negative 1 is negative 2 plus 0 equals negative 2, and that is true as well. So we know negative 1 and 0 is the solution. So we know if we graphed both of these equations, these linear system of equations, they would intersect at negative 1, 0. Okay? So it's okay if you're feeling a little confused right now. It's okay. Let's work on another one. So we have 2x plus 2y equals 3 and x minus 4y equals 1. So like I mentioned before, we want to look and see which one has a coefficient of 1, if any of them do. And this one does right here. This has a coefficient of 1, this x. So I'm going to solve for that 1x there, so I'm going to add 4y over. And I do that because that's the simplest step to take. Okay? Because remember, step 1 says solve for either of the variables. And you want to take the least amount of steps to get that variable alone. So we have our equation. We have what x equals. Okay, remember we solved for x in the second equation. So now we're going to plug in what x equals into the first equation for the x. So here's the x right here. We're going to plug in what that equals. So 2 times 4y minus 1 plus 2y equals 3. Okay, now I only have one variable left, y, so we're going to solve for that. So I got to distribute first. 8y minus 2 plus 2y equals 3. Combine like terms, 10y. I'm going to add this 2 over right now actually, equals 5. Divide by 10. Y equals 5 over 10, which is 1/2. So we know in our ordered pair we have 1/2. So now plug this half in to the equation that we created. So we have x equals 4 times 1/2 minus 1. Well, 4 times 1/2 is 2. 2 minus 1 is 1. So I got 1 and 1/2. So now we have to check these in both of our equations. So let me rewrite these. Okay, plug it in. 2 times 2, or I'm sorry, 2 times 1 is 2, plus 2 times 1/2, which is 1. So 2 plus 1 is 3, so that checks out. 1 minus, well, 4 times 1/2, because I'm plugging the 1/2 in for y, is 2. So 1 minus 2 is negative 1, so that checks out. So my solution would be 1 and 0.5, or 1 over 2, however you'd like to label that. Okay, so I put another example in here. So I have 3x plus y equals 5 and 2x minus y equals 10. So step 1 again. Look at which one has a positive 1 coefficient. And this y right here has a positive 1 coefficient. So you're going to subtract the 3x over. So y equals negative 3x plus 5. This car alarm going off behind me. Just make sure it's not my car. And so we solved for the first one. So now we're going to plug in what we found. So y, we're going to plug in negative 3x plus 5. So now this one's a little bit tricky with this subtraction sign here, so you got to be careful. So really this is saying 2x minus parentheses negative 3x plus 5 equals 10. So really I have to distribute that negative first. So really this is saying 3x minus 5 equals 10. Combine like terms, 5x minus 5 equals 10. Add that 5 over. 5x equals 15. X equals 3. So again, step 1, see which one has a coefficient of 1. Solve for that one. Okay, get that variable alone, which we did here. Step 2, plug in what that equals, that variable equals, into the second equation's variable. Okay? And then solve for that opposite variable, which we did. We solved for x, got x equals 3. Now we're going to plug in x equals 3 into the equation that we created. So y equals negative 3 times 3 plus 5, which y equals negative 9 plus 5, which y equals negative 4. Okay, so rewrite the equations. So 3 times 3 is 9. 9 minus 4 is 5. That checks out. 2 times 3 is 6. 6 minus a negative 4 turns into a plus. So 6 plus 4 does equal 10. So that checks out as well. So this is our solution. Okay? So this is the most important thing. You got to truly understand what this is asking you. If I can erase that or not. Maybe not. So, first of all, solve one of the equations for one of its variables. So we solved here. We look at the coefficient of 1. Okay, so we solved for that one, and I'm telling you that's the easiest way to do it until you're given problems that each of them have a coefficient that's greater than 1, or maybe less than negative 1, or less than 1, I should say. And then we'll talk about that at another time. But okay, really look at which one would be easiest to solve. Okay, so we solve for one of its variables. Substitute the expression from step 1 into the other equation and solve for the other variable. So we solved for y. We got y equals x plus 1. So we plug that in for y in the second equation and solve for the other variable, which is x. Then substitute the value, I misspelled that, from step 2 into the revised equation from step 1 and solve. So after I solve negative 1, I'm plugging that back into the equation that I created. Okay, which I did right here. And I got negative 1 plus 1, and that's how I got 0. And then you run check solutions. Check the solutions in each of the original equations, just to verify you the right answer. Okay, so go through again if you need to watch that. If you have any questions, feel free to email me. Here's your homework problems. So here's number 1, put equation number 1 and equation number 2. Here's question number 2, equation number 1 and equation number 2. Okay, so think about this first one if a variable is already by itself with a coefficient of 1. Okay. This one might look tricky, but it's not tricky, trust me. You already have this set by itself, so you know x equals 2y, so you can plug in 2y for x then, and then go on from there and solve. Okay? If you have any questions, let me know, and I hope you have a fantastic weekend. I hope to see your parents these next couple days, and take care, be safe, and I'll see you on Monday.